This is Scott from fairlynerdy.com, and this video is to show how to use a Z-test for hypothesis testing to see if something is statistically significant. Alright, so here our problem is that the average birth weight for an American boy is 7.5 pounds, and the standard deviation is 1.25 pounds. So they've given the birth weights for the hospital in a certain city, and asked us if we can conclude with 95% confidence that they're greater than the average. So here's our data. We have 30 data points. 30 is really about the minimum number you need to do a Z-test. You can get away with 20. 20 is probably the absolute minimum. Some people recommend between 20 or 50 to do a Z-test. Otherwise, you're doing a T-test. This is our equation for a Z-test to get the Z statistic. So we need the average of the population, which is provided here at 7.5 pounds. We need the standard deviation of the population, provided here at 1.25 pounds. We need the mean of our sample and the number of our sample. So the number of samples is 30, and we get that. It's easy to do in Excel with count. So just count of all these cells, and I get 30, obviously. The mean weight, in this case, is 7.83. I'm just doing that with an average function, equals average of these values. This is the population and population mean weight and standard deviation. So the difference, this top, the numerator of this function is the difference between means. So this is going to be 7.83 minus 7.5. The Z statistic will be the numerator divided by the denominator, so it's going to be 0.333 divided by the standard deviation, which is 1.25, which is itself divided by the square root of 30. So that's 0.333 divided by, and then in parentheses, 1.25 divided by the square root of 30. I get 1.46 standard deviations. So now in Excel, it's easy to look this up into a probability, a cumulative probability with this NORM.S.DIST distribution function. And I can put just this value in. I use true because I want the cumulative value. I get 0.92 as my one-tailed probability. And then if I subtract that from 1, I get 0.0721 as my the tail value, not the cumulative value. Here I'm going to conclude that 0.072, so 7.2%, is greater than 0.05, so I cannot say with 95% confidence that birth weights are greater than the average. It's suggestive that they're the case, but I can't say that with confidence. If I didn't want to use Excel, if I just wanted to use a Z-table, here I've pasted a copy of a Z-table I made in Excel using this NORM.S.DIST distribution function. And I could go in and find 1.46, so I'd go down my left column until I get to 1.4, and then over until I get to 0.06, and then where they join is 0.9729, which is this function. And once again, subtract the two and get 0.0721. This is pretty much how you would do it if you were doing it in a test. Of course, you'd probably have to, this is how you do it if you're doing it in a test or by hand. If you just want Excel to do all the work for you, you can use this function Z.TEST. And then here you will, if I go Z.TEST, the first thing is put in all my data, so the array is all my data, and I'll select all 30 values. The second thing is my population average, so what am I comparing against? What do I want to test against? In this case, it's 7.5 pounds, so I'll just plug that in. And then it's the population standard deviation. That's what the sigma is. It's in brackets because it's optional. I can put in 1.25 pounds. Because it's given to me, and of course I get this 0.0721 number once I make the same format. if I don't put in anything, equals Z.TEST. If I don't put in anything, I'll select the same values, 7.5 for an average, and then I won't put in a sigma. I'll just close it out. I get a value that's slightly different, actually a fair bit different. And what's going on here is because I didn't feed it the population standard distribution, it used the test standard distribution from this, the sample standard distribution from this data. So since I didn't give it a standard distribution, it used the sample standard distribution from this data, which it got basically from standard distribution STDEVA. And you can see this 1.5 standard distribution in the data is greater than 1.25. And that's why that this 0.11 value is greater than this 0.0721. So if I go back to Z.TEST, my array, my x value is 1.5. And if I were to use just this value, let's say this was the population value, I see that's where the data come from. Typically, if you're using a Z.TEST, you have the population standard distribution. Otherwise, you'll probably use a T-test, which is somewhat different. All right, so thank you. If you want, so I've made at my site fairlynerdy.com. I put together just an easy cheat sheet to see what are the different types of hypothesis tests. What are the purpose, and then why would you use one instead of the other? And then the equations for each of them if you're doing them by hand, or the Excel function if you want to do them all in Excel. And you can get that at www.fairlynerdy.com/hypothesis testing cheat sheets. All right, so thank you.